You probably owned a few of these. You might still remember pulling a holographic Charizard out of a fresh pack and knowing, before you could even read it, that you had something. In February, one Pokémon card sold for $16.5 million. But here is the stranger number. 2 cards come off the same sheet on the same afternoon, carrying the same picture. One is worth a cup of coffee. The other is worth a very good house. And this is not another video about opening packs. We like those as much as anybody does. This is about the machine. About how these cards were physically made, and about how that machine decided, before a single human being had ever seen them, which ones would be worth a fortune and which would be worth nothing. And every strange word collectors use for them: shadowless, reverse hollow, cosmos foil, first edition. Every one of those is a description of something a machine did. We are going to go through all of them. Here is the thing that should not be possible. Take a box that has been sealed since 1999 and never opened, and stored perfectly ever since. Cut the wrapper today, and a fraction of the cards inside will come out already damaged, scratched, off-center, marked with a line that runs clean across the face. The wrapper did its job. Nothing got in. And the damage is still there. A card does not begin as a card. It begins as a sheet, a little under a meter wide, and it is not one piece of paper. It is a sandwich, a printed face, an opaque core, a printed back, pressed together. And the core is not there for looks. It is there to stop light. Print a picture on both sides of ordinary card, and the 2 pictures fight each other. You can see the back through the front, faintly, and everything goes muddy. Put an opaque layer between them, and each face becomes independent of the other. That one decision is also, by accident, the best test anyone has for a fake. Hold a real one up against a strong lamp, and it stays black. It is also why a damaged edge shows up white. The layer underneath was never printed on. On that sheet sit 121 cards, 11 across and 11 down, lying on their sides. And here is the number that decides this entire film. 11 cards, at 88 millimeters each, come to 968. The sheet is 991. That leaves 23 millimeters of spare paper, not per card, across the whole sheet. About 11 millimeters at each edge, and that is the entire margin for error that everything downstream has to work inside. Now, the shiny ones. Everybody assumes the shine is something added at the end, a coating, a finish, sprayed over a finished picture. It is the exact opposite. On a holographic card, the foil goes on first, bonded to bare cardboard with heat and pressure before a single drop of ink exists anywhere on that sheet. The picture is then printed on top of the foil. And because ink is opaque, the artwork does not sit on the shine. It hides it. Every place you see color, the foil is still under there, covered. The only places that flash back at you are the places where nothing was printed. The shine is not decoration added to a picture. The picture is a mask cut into a mirror, which tells you immediately what a reverse hollow is. Same card, same machine, mask inverted. White ink goes down over the art window first, blocking the foil underneath it, so the frame shines and the picture sits flat and matte. Not a different product. The same idea, printed the other way round. And the shine itself changed over the years, because the material changed. The first English cards carry a pattern of little starbursts. Later runs use a field of dots, which collectors call cosmos foil. Those are not drawings somebody made. They are different rolls of foil, loaded into the same machine in different decades. Even the gold ones are not printed gold. A gold frame is stamped on afterwards, with heat and pressure, in its own separate pass with its own separate tool. The printing itself is done by a machine that goes out of its way not to touch what it is printing. It is called offset lithography, and the word offset is the whole idea. The plate that carries the image never meets the paper. It hands the ink to a rubber-covered cylinder, and the rubber hands it to the sheet. The plate is hard, and it holds fine detail. Rubber is soft, and it can press into paper that is not perfectly flat. So the machine splits the job in two and gives each half to the material that is good at it. But before any of that, there is a stranger problem to solve. The plate is flat. There is no groove for the ink to sit down in, and no ridge to lift it off. The picture and the background are on the same level surface. So the plate is not carved. It is treated. The areas that carry the image are made to attract grease, and everything around them is made to attract water. Then the plate is wetted before it is inked on every single rotation. The water settles into the blank areas and refuses the ink. The ink settles into the image areas and refuses the water. A machine that prints millions of cards a day is running, at its heart, on nothing more than the fact that grease and water will not mix. There are 4 of these units in a row, one for each ink, and the sheet is carried from one to the next by mechanical fingers that grip its leading edge. By the time it comes out the other end, the picture is complete. And it is, at that moment, in exactly the right place. Then the sheet leaves the press, and this is where it goes wrong. Because the sheet is squared up twice, by 2 different machines, and they never meet. At the press, it is set by a row of stops that the paper is pushed against, lengthways and sideways, so that every sheet enters the first unit in the same position. Hours later, at the cutter, it is squared up again, against its own marks, by a different mechanism in a different building. If those 2 agreements differ by even a millimeter or 2, the picture is still perfect and the card is still ruined, because the blade comes down where the second machine thinks the sheet is. So the border eats itself on one side and grows on the other. And notice what that means. The blade was not wrong. It cut exactly where it was told. The sheet had moved. Grading companies put a number on that drift, and the number is public. To reach the top grade, a card's front border has to be no worse than 55 to 45, meaning the wider side may not be more than about 1/5 larger than the narrow one. The back is allowed 75 to 25 because nobody looks at it. That is the whole of it. A published tolerance of the sort you would find in any machine shop, applied to a picture of a cartoon animal, and worth the difference between a card you would leave in a drawer and a card that goes to auction. The grading scale did not invent that standard. It inherited it from the press. And here the argument runs into a wall. Because if these faults belong to the sheet and not to the card, then thousands of cards came off the press on the same afternoon in the same condition. A perfect one should be ordinary. It is not. Of one famous card, a little over 5,000 have been submitted for grading, and 124 came back at the top grade. 2.3%. And the reason is that these tolerances do not take turns. A card has to survive the centering, and then the edges, and then the corners, and then the surface. Pass 3 of those and fail one, and you have an ordinary card. The odds are not added together. They are multiplied, and multiplying together 4 numbers that are each merely likely gives you something that is not likely at all. So let us go and look at the other 3. The cutting itself is done by a steel die, and the corners are a separate operation. On a modern line, all 4 corners are struck at once. On the machines of the era that made the famous cards, the cards were cut, stacked, carried along on a chain, and then pushed sideways under a beam that fell on them. And in the patents of the period, that beam's own weight supplies anything from half the force to all of it. The machine falls on the cards as much as it presses them. If the blade is sharp, the card separates cleanly. If it has dulled, it stops slicing and starts dragging, and it tears the paper fibers instead of parting them. That is what edge whitening is. It is not wear. It is the moment of birth recorded. And the corners carry more information than they look like they should. A square corner, on a card that is supposed to be round, is not a scuff. It is evidence. It means that card missed the corner die completely, and a card only misses the die if it went in crooked. So a square corner does not tell you somebody was careless with it. It tells you the card came off the line wrong. Now the marks that sit in the middle of the face. A rubber blanket is a consumable. It picks up a nick or a speck of dried ink, and from that moment on it carries a flaw, and a cylinder turns. So the flaw comes back around and prints again at exactly the same interval forever until somebody stops the press and washes it. That is what a print line is, not an accident that happened to one card, but a fault with the spacing. Roll that cylinder out flat and you can mark where it will land over and over down the length of a run. On a holographic card it is worse, because the foil sits above the ink with nothing over it, and a reflective surface shows every break in itself. There is one step left, and it explains more than it looks like it should. A pack is not a random handful. It has slots, so many commons, and uncommon, and a rare, and a machine has to fill those slots correctly, millions of times a day, without ever once looking at a card. It manages that by never mixing them in the first place. The surviving sheets from that era are stamped as 1 form out of 10, which tells you the run was split, separate sheets for separate rarity tiers, printed apart and kept apart. So a pack is not scooped out of a pile. It is built from streams. A stack of commons comes from here, an uncommon from there, a single rare from a third. Which means the moment your card was going to be a rare was settled long before anything was cut. It was settled by which sheet it was printed on. Exactly how those streams were brought together is not documented anywhere public. What is documented is what the cards went through on the way, and that is where the damage comes from. Which brings us back to the sealed box. By the time a wrapper closes around a card, that card has already been cut out of a sheet, dropped into a stack, carried along a chain, shoved sideways under a beam, struck at the corners, slid against its neighbors, and finally pressed by a heated jaw that seals the foil around it. The graders are direct about this. A share of the damage they see is inflicted before the pack is sealed. The wrapper is not a time capsule. It is a lid that goes on at the very end of a rough journey. It protects the card from you. It was never able to protect the card from the machine that made it. And one honest gap? Nobody has published exactly which surface scratches the shiny ones on their way through. That part is not documented, and we are not going to invent it. There is one more thing the press decides, and it is the largest of them. The first English cards were printed in 3 windows, and the difference between them is not the picture. In the first, a small stamp went onto the card, and that stamp is what collectors mean by first edition. In the second, the stamp was gone, and there was still no shadow behind the artwork box. Those are the ones called shadowless. In the third, somebody added a drop shadow, a printing decision, made at the plant, of the kind that would normally be invisible to everyone forever. Those 3 windows are now 3 different prices, and the gap between them is enormous. Not because one card is rarer by design. Because a plate changed on a particular Tuesday, and nobody thought to write down which. The publisher that contracted this work out to a Belgian card printer in 1999 now owns its own factory in America. And the most expensive card that industry ever produced was never sold in a shop at all. It was a prize, handed out in a competition, and 39 of them were ever given away. Of those 39, exactly one has ever been graded flawless. In 2021, a YouTuber, Logan Paul, bought that one privately for a little over $5 million. In February this year, he sent it to auction, and it sold for $16.5 million. Both halves of that number were decided by a machine. How many exist at all was a print decision. Whether any of them survived perfectly was a tolerance. Which is where we started. The picture is the same on every copy. It always was. What separates them is where a blade came down on a sheet that had moved about 2 millimeters 25 years ago, in a building where nobody knew and nobody would have cared.